right. So as I was saying, up until 2022, 2023, we knew pre-training, fine-tuning, reinforcement learning through human feedbacks. There's this whole other thing of reasoning and things like that. But anyway, some of the secrets were being kept secret. But then we got DeepSeek, which, the model, if you use it, is essentially as powerful as GPT-4, right? So it was a pretty good model. And the new thing is that they published everything. So they published the papers. You can go look at the GRPO math paper and the DeepSeek paper itself. And so they told us everything that they did to create a model similar to GPT-4. And as it turns out, it's essentially this pipeline. There wasn't anything there different. They did, update some things, like they didn't use the original PPO. They were using some new technique called GRPO that's more robust, right? They had a new heuristic rule for the reward function. And then, of course, there's the whole reasoning thing. That's where you create. So if you remember initially, you would just ask the GPTs a question and they would give an answer, right? But no one expected them to reason about things. But later on, we actually got models that reason, right? And actually do a pretty good job. So as time permits, I may get to that topic, but that's a whole other thing, okay? All right, so yeah, so essentially then, we've covered today this part of the class, which is as far as we'll take it in terms of creating a powerful GPT-2 in code at least, and this is your homework assignment that you need to implement. So remember, all you need to do is you can use this code, get a powerful GPT as much as you can, and find a BERT score, right? So either one from the Hugging phase, one via zero shot, or in the next section today, I will show you how you could possibly train your own classifier with your own text, with your own things. Does this make sense? Any questions? All right, so let's actually assign the homework officially. So let me go here. So you guys are still working on your autoencoder homework. That was homework 1, I believe. That's due a week from today, right? We're currently on week 4. That's due week 5. Keep in mind you have exam 1 on week 6, okay? So in 2 weeks from today, you'll have your first exam. All right, so let's do this homework for week 7. How about that? So that way you get 2 weeks, you get 1 more week to finish the autoencoder, submit a week, and then from there you have 2 weeks. Is that good? All right. All right, so let me do that. And you've had 2 homeworks this semester. So let's go to the table of contents. Yeah, so I'll put the date here. So RLHF. I'll just copy this whole thing. Control copy. So I will create the link, new assignment. Let's call this RL reinforcement learning through human feedbacks, RLHF, homework, TRL, okay? So that you know this assignment. This brings you full circle from 520. All right, so let's do due date, as I said. So the autoencoder homework, I believe, is due on the 11th. Exam on the 18th. So the 25th, correct? 2 weeks. All right, it'll be until 10. So 25th. So that gives you until March 1st, a Sunday, to make sure to submit. Just be aware that you have to present on that day, right? So I'll allocate like the second half for everyone to present, just short presentations with your results, and that, so we can have a discussion about it. So I'm going to click save and close. All right, so we should be done with it. Okay. All right, so I did this. Now I'm going to focus on, I think this one actually. And then this BERT rewards, I may skip this semester. I'll leave it for next class, I'll decide. All right, so now, this is close to being done. All right, so the second half of today, right? Let's talk about the second half of today. So I'm gonna close this because we're done with the whole TRL, and we discussed it. Now let's take a look at this module here. All right, and I have a code example again, same idea. The BERT model, right? So you need a BERT model to use as a reward function that's going to provide scores, okay? So as I've said many times, you either get one that already does the job, like a phishing one. You use zero shot. That may actually be a really great solution. But what if you just have like a very unique problem, right? And there is, in fact, no existing BERT score for that. Zero shot doesn't achieve it for you. So what do? You have to essentially train your own. So essentially, we're going to build a classifier, but it's a classifier using a large language model. That's exactly what we're doing. All right, so let's take a look. I do need, so I click on the code link. I do need some data for this. So I already loaded this data on my Google Drive. All right, so train CSV and test CSV, and also review CSV. But if you guys want to replicate this, just download these data sets, okay? And then the code should be this one, fine-tune a BERT classifier, and maybe I double-checked it the other day, so any little fixes for 2026, they're going to be in here, okay? And I'll go over this demo. So let's look at the data first, just to get a feel for it. So train CSV. Remember, we are locked in on Hugging Face's workflow. So essentially, we have to learn how to format things the way that they like things. So here you can see I have the sentences followed by what? A label. Do you guys see that? That's it. So this is how you would format your problem, right? So if you want to, train a model, you would, so notice, for instance, I have some sentences with a 0 for the class. Others have a 1, right? Zeros, ones. And there's quite a few examples here. So this has 8,562 samples, right? Should be. Yeah, so there should be about 8,000 samples in there. And it might just be skipping numbers. You can see it skipping like 44 to 46. So that's why this count is going up faster than this one. Do you guys see that? But there's about 8,562. And you have a sentence, like in this example, and the corresponding label. So essentially, it's a two-class problem, zeros and ones, but that's perfect for a reward function because remember that it's actually a logit, right? So it's going to be from 0 to 1 and anything in between, and so that might be very helpful. Got it? Yeah? All right, so this is the data that we can use, and the rest is obviously text and sentences. So again, I point out, when you pre-train, you need essentially the whole internet, millions and millions of examples, but once pre-training is done, fine-tuning is 8,562 sentences, 100,000 sentences, so something that's definitely manageable for us, right? So that's why I was making the joke that no one in industry is really pre-training their own models except really large corporations, Mistral, OpenAI, Google. But a lot of people can fine-tune because even with one GPU and a few examples, you can get some results that might be reasonable for your problem, okay? Especially if it's a very unique one. So this assumes it's a very unique one. All right, so that's it. That's the data, right? Okay? We can take a look at test CSV, right? And test CSV does not have labels, so but we just need those sentences to predict something. Okay, so that is the example. So now let's go back. Okay. Table of contents. Okay, so we're here. Code. All right, so the example I'm going to do is this one and this BERT. So let me open this in another tab. So I have both. Right, so this has the corrections, if any. And this is just so that we have the output. All right, let's start sort of with the end. Right, so the end is we train the model, right? And the loss goes down. In my example, my code, I do have the inference part, so I'll be able to give it some text and it'll assign a class. Okay, so we'll take a look at that in a second. But this is the example. All right, so I have to start a new collab at this point. So, oh wait, did it finish? Yeah. All right. So green check. I've been stalling all this time, making up stuff. All right. So yeah. So it finished, right? 194 iterations, and it did it what? 43 minutes. Yeah. So there you go. Not too bad, right? Not too bad of a homework. Hopefully, this is still in memory. So let's see. The next part would be to run this code here. Gave me an error. It's this logic here. It's doing the same thing. I didn't have because I it was taking too long. I didn't. It's okay. So all I need is instead of this output 1 score. I don't think it's output 0, but really? Are you using like the modified code or are you using the old code? From the PY? From the PY, yeah. And you're using, that's the issue. So maybe if I do output score, it'll work. Let me try this. So I'm gonna move. Okay, I got a green check. All right. So it did, yeah, it's like I said, I made that modification because my code only is generating, like, it depends on the version probably. I must have a later version, and it's not giving me the benign and phishing, both categories. It's only giving me like the top one. So that's why I had to do an if statement, and that's why you may need to tweak your code a little, okay? Or use the code the other Jupyter I gave, but make sure you have exactly all the same libraries. That's the issue. All right, so now let's take a look. So great. So we were able to run it in 43 minutes. Let's take a look at it to see what you guys think. Okay, so I have a query. Let's look at the first one. I gave this movie a 2. That's the prompt. Then I have a response with the reference model that was not updated and a response with the updated model. So the reference model says movie at 2 and exhausted something will die. The response after says it's scored out free for $5 and $6 you can watch. What do you guys think? That's not something you would see in IMDb, right? As a comment for a movie. Does that seem spammy to you guys? Yes, right? Okay, good. So that seems spammy. Now look at the score. This makes sense to me. The BERT model, the BERT score says that this one is more likely to be spam than the other one. Do you guys see that? So good. So I think that's a good example, right? The Story Chronicles versus promo, $25 anything, $25. Again, probably spam. It is 5.89, a little bit higher on the this one. Click here for a link, obviously spam. Versus this one, no Wi-Fi to enjoy the network as well, so not spam. This one, actually, the score though is giving us an error. So it's never gonna be perfect, right? So the better BERT that you have, the more training you do, probably the better GPT-2. All those things would contribute to improving the quality of your work. Purchase it now, definitely. So it's almost like it is converting the text to spam, but our reward function is not always working very well for some reason. And I'm suspecting, I wonder if it's just that I have an error in my code. That's right, right. I think it's again this problem, right? That sometimes it switches from benign to, and I think that's what's causing this error. So I'm gonna have, unless you can see the solution to this, I would have to think about how to solve this a little bit. Do you guys see what I'm saying? I think that's what's being reflected here because obviously, uh-huh, show the label. Well, it's kind of like code I had here. So this rewards, where this line below, this one, oh, the if statement. Um, yeah, if output label, okay, so something like this. Yeah, that's the issue for sure, is that I didn't double check this part. So output, so we would have to do it here, right? So what do we need? Sentiment analysis. Okay, sure. Rewards before, rewards after. I guess output score. Okay, I think, let me try this. So, oh, if we, it would be something like this, like output score for output score and sentiment if output label equal phishing else 0. Huh? Why another column? Okay. Do you know the exact code for that? Because I don't. All right. Tell me. Where? Wait, hold on. Which line? This line? Okay. Just below it here? The other one? There's two game data. Okay. Change this to just benign. Just label. Okay. Just so that we can see it then. Oh, okay. But one of them is still going to be wrong. Okay. Just like this? Okay. Try this. Okay. Okay, yeah. Good. What I was trying to do is if you put the if statement here, then if the label equal phishing, it'll give the actual score, else 0. So we won't get, but at least the scores would be correct, right? So here it said it was phishing. See, but this one is higher, benign. Yeah, what I was trying to do is just add this. Hmm. I have to think of the syntax for this. All right, I'll try to fix it later. I'm just gonna copy this. But you guys get the idea, right? So what I got wrong there is that's tripping me up. Anyway, all right, I'll leave it there. Hopefully it stays there. Let's try to finish the other example. Okay. So here, as I was saying, we're going to train a BERT model to be a classifier. Okay. So we need to bring in Colab again. All right, so let's add code scripts there. All right, so we need the data. So I need to mount the drive. I already mounted these files. Connect to Google Drive. So the sentences with the labels. So they should be in there. Okay. Then I'm going to read in the data. Okay, so train and test data. All right, let me, I guess, sure, to download this one. That's test, then train. Also review, just in case. All right, then I'm going to add these to Google Drive. Okay, so should be loaded now, hopefully. I don't know. I hate this thing. Anyway, so it worked now. Okay. All right, so maybe it was just taking a while. But yeah, I swear I loaded these yesterday. Okay, so now I've got the data. Remember, again, the key thing is you put the data in that format. You're gonna then convert it to the format that the workflow of Hugging Face. There's things that need to be replaced. So, for instance, ID to IDX, text, sentence, etc. Label to target, things like that, right? So this is a mapping or renaming of the data. So let's go ahead and do that. Okay. Right, so that should be done now. We can take a look at the data frames with the data, essentially. And there it is, right? So you have your sentence, your label, and this is what the format that Hugging Face expects. Then we're going to bring in this data and get it ready to process for the fine-tuning process of this classifier. Okay. So we saw already that there's ones and zeros and all of that in these sentences. We can take a look at the test set, which we will run in the end once the model is trained so we can actually do some predictions, okay? with the trained model. So you can see this is our test set. We have about 3,263 samples. Okay. Now let's go ahead and load. Remember, we use this data sets and load data set special modules from Hugging Face to kind of format everything in the format that they expect. So load data sets, dataset dictionary. So we create the data sets from the data frames, the pandas data frame. Okay, green check. There we go. That's good. Right. Now, again, we can look at the data sets for our reference. Data set, there it is. So this specific format, number of we had seen before, right, that they use 7,000 examples, sentence, and label. And they have these like specific tasks. These were like competitions that they had on language understanding, question and answering, all of that. It's called a COLA, I think. For my example, I'm just using the sentences and the labels. So we'll see that. But we're using like a specific format. All right. We can take a look at the test data set as well. Okay. And you can see there's about 3,263 sentences in that. Okay. We can also look at a specific sample just to confirm. And you can see there's a sentence in there and a label and so on. All right. Here we have the tokenizer, essentially, some processing. They had when they created this challenge, it's almost like you would enter 8 competitions that are different. Do you see what I'm saying? So some of them had question and answer, some had like something called entailment, some had like summarization, various things. So they had this notion of a sentence one and sentence one key, sentence two key, right? And that just means that maybe sometimes you did have a question and an answer for that task. So that's all that this is doing, okay? It's like overcomplicating things. We just end up using sentence one key here, okay? But this is the process, like I said, I'm kind of like adapting this to be able to train a classifier. All right. So here they are, actually, the tasks to keys that I was talking about. So our example is just COLA. We just have sentence, and the other key is going to be none. But for other tasks, they did do premise, hypothesis, sentence one, sentence two, and various other things, right, for the various tasks. But I'm only doing one. So the other ones are being ignored. Okay. So the task is COLA. Okay, model checkpoint. This is going to be a Distilbert base uncased. So it's a BERT model, obviously, because we are, in fact, training a classifier, right? So it's a BERT score where text goes in, but some kind of a score comes out. It's uncased just means no uppercase letters. Batch size of 16. All right, so this is just going to be for the tasks, the keys. So we can see that. If we print them, Our text just has sentence, right? So there's no, if we had in our text, we'd have like question, answer. We would look for those headings to extract the data, but in our case, we just have a sentence and a label. All right, the next part is going to be the tokenizer as usual. So from transformers, auto tokenizer, the model checkpoint should be that BERT base, the distilled BERT. And that's the corresponding tokenizer that converts the strings to integers. Remember? All right, so we got a green check. We're going to encode the training set. So with the standard workflow that Hugging Face uses, take the train set, dot map. There's a function, preprocessed function, which is the one that we define over here that uses the tokenizer itself. And now we have an encoded training data set. Right, so now we're going to bring in from transformers the auto model for sequence classification. So this, if you guys remember, when we did the baby BERTs in the previous discussion, that's the head, right? That last head that provides, from the embedding to what you're going to output, right? CLS goes up. So here we need to specify that it's two labels, 0 and 1. Okay. All right, so here now we create the model. So auto model for sequence classification from pre-trained model checkpoint to the stillbird, and then we have two labels. That, brings in the BERTs, or pre-trained BERTs. Some metrics that we can use, the metric from our library, and the model name that we're going to use for the checkpoint, the model checkpoint, model name. We can print model name. This is still based on case, right? So when we save checkpoints, etc., we can save them like this, okay? So now, training, the usual approach, right? So training arguments. Okay, you can always specify here the path, right? So if you want a different path, a specific location, you can just add it there. So model name, fine-tune the task, eval strategy, epochs, just default parameters, learning rate, the batch size, number of epochs is about 5 epochs, and a few other techniques, weight decay, etc. So you can play with these parameters. Metric name is accuracy, right? Okay, so that's defined. Good. Yeah, evaluate. I think I had to install that library. That's so we can use the performance metric, I believe. So compute metrics for the specific tasks. Okay. Oops. So let's bring these in. So it's giving me the error, so I have to install it. All right, let's give it a minute. Okay, so it installed, hopefully. Let's try this. All right, so we get a green check. Okay, so, we got our library. We just ran this. The metric, we tell it is, we want from evaluate this accuracy metric, which is the appropriate metric for this task. We don't have labels in the test set, unfortunately, so. But if we did, we could evaluate the performance, which actually not bad. All right. Data collator. This use a data collator to handle padding, which avoids the tokenizer keyword issue in trainer. So this is a workaround for a warning. I think you saw me that I didn't use data collator in other tasks, but this has become part of the workflow, as I've seen of late. Okay. All right, so that's specified. Okay. We're getting close to being done. Validation key. Let's just add this. Again, some of these things are to handle the various challenges. So there's this MNLI, which you may have seen. So just use the default value there. And now we are at the trainer. Okay, so notice the same idea. The trainer has the model, brings in the arguments, brings in the encoded training set. I don't have an eval data set here. The data collator, which is related to the tokenizer, and then the compute metrics, which was accuracy. So everything comes in together there. 1 dB, this is just some like company, so I just disabled that. Or weights and biases, I think it's called. All right, so just disable it if it's giving you issues. Okay, so that worked. All right, so now we should be able to start the training. For the fine tuning, right? So trainer.train, same workflow. Click the green arrow. Let's see how fast it goes. Three, 4. It's kind of it's going slow, right? I think the runtime is still CPU, I want to say. Yeah. So let's actually, it makes sense to switch to GPU so that it's much faster or faster. I don't remember this being slow when I tried it. So we'll just have to rerun this. So change the runtime, T4 GPU, click save. Yeah, I have too many sessions. This is 58. So unfortunately, bye-bye. Yeah. Okay. I wonder if you have premium. Can you have multiple? Probably, right? 2. Yeah. I don't have premium. All right, so change the runtime. Yeah, T4 GPU, click save. All right, so let's run this. Oh, it's mounting the drive. This is the fun of modern day AI. Yeah, you have to deal with GPUs and lots of things like that. Okay, so that worked. This worked, right? So this is loading the data correctly, converting the data set, train data set, test data set, an example, creating the function, the usual workflow, right? A function for the tokenizer that can help us to map. The task is call, as I said. This was just a basic fine-tuning of a BERT classifier. Bring in the model. This is not the only tool that we will use for fine-tuning. This is for language models, but we will use for image, for instance, FastAI, replicate.com. Okay, so that is done. Encode the data. That's done. The head and the two labels. That's done. The model. All right, so that's done. The metric. The arguments. Yeah, we have to probably install evaluate again for this environment. Give it a minute. Okay, that's done. Libraries are loaded. That's done. Metric. Collator. The training arguments, or no, actually, this is the trainer with all where everything comes in together. So that's the BERT model that we're going to fine tune. Weights and biases disabled. And now, hopefully, we can train a little bit faster, right? Yeah, much faster, right? So if you remember, just at 2, 3, now we're up to 60 something. We do have to wait a little bit, but we have time. I want to show you the inference part of this, so we have to pre-train or sorry, fine-tune them up. Does this make sense, guys? So this is actually the toughest lecture of the whole semester, right? Because this is, it's really three models for the TRL, GPT, the distilled GPT, the reference distilled GPT, and the BERT. So that's actually a lot of memory. I don't know if you guys appreciate Colab is really powerful, okay? Doing this is in the past, years ago, I would do this on my RTX 2080. And yeah, it didn't take 43 minutes. I think it took like 2 hours. And I would constantly run out of memory. And I had to so the combination that I was able to get to work is that distill GPT, and so on. So yeah, Colab is powerful. This is actually makes it look easy. It wasn't always easy. All right, but yeah, so far we've been successful. We got TRL working, right? We actually got it to work. It just has that little error, which I think you guys can fix, right? So you guys can, because it's key that you are able to print the score before and after, okay? And now it's gone for me, unfortunately. I have to kill the environment, so I'd have to start the training again, all 194 iterations. So I'm not able to fix it. But I leave for you guys to figure out. I think that if statement that the approach that I was trying to do here would have worked. I just got something wrong. But when you do a list comprehension, which this is, you can put if statements in there. Like if you notice, all I'm doing is for output and sentiment pipe. I'm iterating through it. Then output gets processed here. There is a place in the list comprehension where you can put an if also. And so this should have been, like I'm missing something, but something like if output label equal phishing else 0. Something here I did wrong in where I placed this. We can literally probably just ask ChatGPT and it would give us the right one. But at this point, I cannot test it anymore, unfortunately, because this is gone. But yeah, anyway. So that otherwise, though, TRL is fine. You said, Blast, that yours ran fine as it was, but I think you used the exact version, okay? So that's the key thing. I did provide those parameters. Python, you must have used Python 3.8 and then installed the appropriate TRL. All right, so just play with that. But overall, it did work. It gave us a result. Just make sure, please, the scores are gone, but just make sure that template looks good because that's actually the only way that I know that you succeeded in training your model. Remember, maybe as time permits, we can go back to that IMDb example, but remember, there is another example in there. So let me look at this. Yeah, actually, look at it. It's moving really quickly. It's almost done. Just remember in the RLHF module that I gave you, there is a second example, this one, GPT-2 sentiment. So I can also maybe discuss this one just briefly while we're waiting for it to finish. So essentially this captures the idea. And I think this is your question. You were like not sure that this was true, but it is true, right? So there is a query. It goes into GPT-2, the actual GPT-2, and it provides a response that should be in connection, just like when you go to ChatGPT, it provides an answer. Then if you notice, there was a query and response plus, they're like concatenated, which we saw this, I believe in previous examples. So when I did sentence 1, separator sentence 2, if you remember, that goes into the distill BERT, and it provides the reward, right? So, or the BERT of some kind. So yeah, so this is an example of sentiment analysis. I believe this one, we can look at it. It uses a GPT-2 IMDb. Right, and then kind of the same logic. The data is IMDb for the prompts. Notice it does a model and a ref model because, like I said, it doesn't want to it shouldn't deviate too much. So it uses the callback labeler, which we are definitely going to come back to these things when we do this from scratch. Obviously, with much smaller examples. PPO trainer does this. Here we load a BERT. Notice in this example, it's the same thing, pipeline, sentiment analysis, or it could be text classification, and it's using a distill BERT from IMDb, which has positive or negative. So you can see that it provides two classes, positive or negative. So for instance, the movie was really bad. So the score, it sends to the top, the winning score, right? So it said it was negative. The movie was really good. So 255 is positive, right? So that's, yeah. So I guess here it's not doing, I don't know. But anyway, it kept the order here. Sometimes it's changing the order. I did try to like a field like maintain order or something. So there's something there that you definitely have to fix. These are the arguments. You train the model. Here is the parameters and the description. See, it used to take about 2 hours with a V100. You saw today it took 43 minutes. So definitely we got lucky actually, I think, with whatever GPU I got. Then we do the training steps, right? The same thing. Notice it puts the query and the response together, right? As text. That is sent into the BERT, right? Both of them together, concatenated here. We do the trainer, does the training process. You can see this is probably something I ran on my GP at home because I remember this warning. And let's go about here. So this is if you use weights and balances, it gives you these nice charts and stuff, but they also want you to post this to their social media sites like a company. So I don't want to be sending things somewhere. And then the model inspection, this is the same code that you guys saw before, the same screenshot, right? So there's a query that goes in, two responses before and after with the reference model, and with the after modification, you can see the scores are printed here. So for instance, these should be more positive. Yeah, here's an example, 14, right? So vampire something, so Borgs and suggestive dead person's flashback versus PO is a wonderful movie. So it's giving a positive review. Do you see that? So if it was me evaluating this, I would be looking for it's a wonderful movie, wonderful film, best writing, probably a masterpiece, right? Very positive there, right? And so you can see this one also, it's reflected in the score, 2.45 versus minus 179. So definitely make sure you get that right in the code. And that's it. So then it just prints out some additional, it saves the model for you to deploy, things like that. Does this make sense, guys? So that was TRL, showed you two examples. Don't use these, obviously, because you have to, so these are just examples, making the sentences more positive, or the previous example where we made the sentences more spammy. So you should find another task, right? However you want to do it. Remember, you can just grab a BERT online, zero shot a BERT, which might be a way to go, or what we're doing today, wrapping up, training our own BERT classifier, right? So let's see where we are on that. So it looks like it finished. I see the green check. Did 2,380 iterations. Let's take a look at the loss. So usually transformers are really good at the loss always going down, right? So 42, 31, 24, 13. This is like textbook, essentially, right? So it looks pretty good. So that means we have, in fact, fine-tuned our own classifier on top of a BERT to take text and predict labels. Do you guys see that? Yeah, great. All right, so now let's go ahead and look at, so this would be, I'm gonna close this. Close that. That's okay. All right, yeah, so we're going to finish up now. So what we want to do is we train the model, so now we want it to predict. Show a few predictions, for instance. All right, so for this one, we train with the train set, right? So now we need to evaluate it with the test set, or, I don't have labels in that test set, but we can at least make predictions. So I have to take the same approach, the workflow of Hugging Face, test set.map, provide the preprocess function, right? And now it encodes my whole test set. Okay, so that's done. Then I'm going to do some predictions. So now I would take trainer.predict, and I'm just going to give it the encoded test set. You guys see that? And I'm going to make my predictions. Okay, so completed. And I have to get the predicted labels because it's essentially giving me the the distribution. So I have to use argmax, NP argmax of the predictions, predicted labels. Okay, so I should have the indices now. And let's do okay, so for I in range 5 of oh yeah, it's the sentence, and this just has the predicted label. Okay, so there we are. What do you guys think? Make sense? Questions? Yeah, please.
Did you use argmax to fix the other problem with the labels flipping?
Over there, the problem is it's giving me the, you mean here, right? Yeah, for the score here, it actually gives me, it's like a very specific format that it uses. So it's giving me, it's a dictionary. This is a dictionary, not like an embedding or like a probability distribution where I can use argmax. That's the problem. So this is actually it's solvable by doing output label equal fishing, like literally. Yeah. So, but yeah, so that's the example for this one to train a BERT score. Questions? Anything? Not impressed? Stuff like this doesn't impress you guys anymore? This is hard stuff. All right. So anyway, so we have at this, I've taken this, to the, as far as we're going to take it, but you now have capabilities, right? So you can, you know how to do pre-training, but you realize, unfortunately, you need massive amounts of data and GPUs. You know that fine-tuning is more within your realm, right? You can customize your own models. We did fine-tuning of GPT, fine-tuning of a BERT. We've done we don't know the theory yet of RLHF, but we know at least how to do it. So we can take a GPT, BERT, do that whole cycle, and update the GPT so that it can make text more spammy, more send positive reviews, whatever you want it, really. Okay? And we know that we can take a BERT from the Hugging Face repo as is. You know how to do zero shot with a BERT, and now you know how to fine-tune your own BERT to be a BERT classifier. Okay? So that's the whole pipeline right there. Beyond this, as I said, what would be left is to jump from 2023 to today. That's the whole reasoning models. That's a bunch of other ideas. But yeah, this is it. So now you have a homework assignment. Just complete this TRL, and then next week we're going to start going more into like the theory again, right? So understanding in particular how to train not an actual transformer, but something simpler, right? With RLHF, using PPO, understanding how PPO works, and getting into those ideas of GRPO and so on. So you can expect those scripts to be more like the baby GPT, the baby BERT, call it baby RLHF, right? So, and we're going to go from there. But so that's more it's going to be for understanding how things work in the background in case you ever modify something. But as far as actually training a model, this, I believe, is how you would have to do it, okay? With a library like this, because you want to leverage these massive GPT and BERT models. Make sense, guys? All right, perfect. So I think this is a good stopping point for today. Like I said, I'm happy that I'm done with this part. And I've demoed it to you guys because it did work, I think. And now you guys can go ahead and implement this on your own, on your homework, and you will present your results. Do something interesting. That's what I recommend. I rather you take longer, but do something interesting, right? Than just do whatever. So you have a lot of room here for creativity and to try out different models. It'd be nice if you could use a Llama 3, more powerful BERTs, but just keep in mind, we are limited, unfortunately, by the resources, okay, which are our GPUs. All right, I'll stay for a few, let me end the video here. I'll post these videos